Hello everyone and welcome to another Physics 211 lab simulation walkthrough. As always, my name is Alec, and today we're going to be having a chat about Faraday's law. Before, of course, you watch this video, please go ahead and read through the theory section of the lab. Noting, of course, that the simulation that we have is slightly different because we're not doing this in person. So, to be specific, I believe this rotostat here is taken out of the simulation, but it won't affect our results, which is good news. So in any case, let's get started. This is a relatively short one, if I remember correctly, so that's good news for us. Go ahead and follow that link to the first portion of the experiment. It starts here. It should take you here. And what we're told to do is to insert the bar magnet slowly into each of the solenoids. We're going to click on both here, and then remove it and look at the sign of the voltmeter, or sorry, the galvanometer actually, and look at the sign and see if it changes or remains constant when the magnet is inserted as opposed to removed. So let's go ahead and do that. And we're also told to mark down which coil gives you a higher voltage reading. I believe there's some data tables down here, so go ahead and use these data tables to fill in your data for this section. This, of course, will be posted on the Blackboard. But in any case, following step 1 here, insert the bar magnet slowly into each of the solenoids, and then remove it. Does the sign change or remain constant? So let's go ahead and see what happens here. So bring in the north end, you can see we deflect negatively, and when I pull it out, we deflect positively. So once again, bring the north end into the smaller coil, we go deflect negative about halfway here, and positive, maybe about 75% of the way. Now, we're told to see which, or we're told to ask, or we're told to figure out which coil gives a higher voltage reading, so I'll bring the magnet down here and we'll see. Okay, so it deflects kind of all the way to the left here, and here it deflects all the way to the right, and you can see the light gets rather bright when we do that. So given that, we'll go one more time here, all the way to the left, all the way to the right. So this is changing directions as we change directions of the magnet here. Now we're told to insert the magnet more quickly into a coil of your choice and see what kind of changes about the measured voltage from the earlier part of the experiment. So what I'm going to do is I'm going to insert this relatively slowly first, just so you can get an idea of what's going on. Okay, so you can see it kind of deflected a little bit here, also deflected a little bit there. Now if I bring it in kind of quickly, you'll see it deflects a lot more. So apparently, the speed at which we bring the magnet into the coil of wires will affect our results. Okay, so now we are told to, we're going to be flipping this magnet around a little bit to see what happens when we do that. It says to note the sign of the voltage when inserting the positive end or the north end of the magnet into the solenoid, so we're going to do that. Alright, so you can see it deflects towards the negative here, and he used the, so let's, one more time here, you can see it deflects towards the negative when I bring the north end into it. And now I'm going to flip it, and we're going to note which direction it goes when I bring the south end in. And as you might expect, it deflects the opposite direction. So one more time just for show. Deflects negative when I bring the north end in, and then deflects positive when I bring the south end in. Okay, so go ahead and mark all of that down in your lab manual here for the magnet solenoid and the speed test, and then we'll move on to the next portion. Okay, we're back with part 2, so please follow this link, and then we will go ahead and start. Also note the data tables for you to put all of your data in are down here as well, just like before. So let's see. After downloading and running the program, select the 4th tab at the top of the user interface called Transformer, which is this one right here. On the right side of the window, select the AC or alternating current option. And then we are told to set the AC current supply to 50% for both frequency and amplitude, which I believe are the default values here. Now, we're told to move the current supply coil into the following positions, basically as far as possible away from the pickup coil, adjacent to it, and inside the pickup coil, and then to compare the maximum voltages indicated at those 3 positions. So let's do that. Oh, and we're going to switch this to a voltmeter as well. So I'm going to bring this over here, and I'm going to bring this all the way over here, and you can see there's not much going on. Your magnetic field is going to be changing because, of course, there's the change in current here, and there's not much happening, right? So here, I would say your voltage, you're pretty comfortable to say your voltage is probably right about 0. And now we're told to bring them close to each other, but not necessarily inside of each other. So if I bring that kind of right next to it here, you can see the voltage kind of wiggling back and forth. If we call this little, this little tick here 1 volt, it's probably oscillating between, I don't know, like 0.1 and negative 0.1 volts. So there's that. And now we are told to bring the pickup coil into, or sorry, this one inside the pickup coil. So once I've done that, you can see now we're oscillating between about, I don't know, negative maybe 0.3, zero point 0.4 volts and 0.4 volts. Let me make sure I'm right in the center here. There we go. So yeah, right around half a volt. It's kind of oscillating back and forth between those two values there. And so make sure that you go ahead and mark those down in your lab manuals. All right, so we are now told to set the frequency to 5%, then 25%, then 100%, so I will do that. And then go ahead and note the voltage changes as that happens. So bring the frequency down to 5%. You'll notice the magnetic field is changing very slowly with this frequency. So because of that, the deflection isn't super, well, there really actually isn't any deflection at all. So now if I bring it up to 25%, right about half, right around half from where we were earlier, 25%. Sorry, my mouse is not very sensitive right now, so it's not. Okay, 25. There we go. Okay, so now you'll see we're getting a bit of deflection. Again, looks like it's between like negative 0.1 and 0.1 volt. And now we're going to take this and slide it all the way to 100%. Oh, there we go. And now you can see we're kind of deflecting wildly, almost between negative 1 volt and 1 volt. And that's because of the quickly changing magnetic field in this case. All right, so that's pretty much all the data you need. If you need to go ahead and look at this video, or watch it once more, or twice more, or, I don't know, 10 times more if you feel like it, go ahead and do that. But that should be all of the data you need to do your analysis and to fill out these data tables and all that. So have a great day, everyone. Thanks for watching.